Hi guys, welcome to Learning Electronics Repair. I have a review and it's a long time since I reviewed a multimeter. So this is from Zotek. It's sold under the Zoyi brand, but the box itself doesn't say anything, no model number or anything. So I do know what this is, but let's have a look. Hopefully it will tell us anyway. And let's see how this performs. I'm especially interested in some of the features we have here. So 20 amps, maximum current. Yeah, that's a bit unusual that. This has a microamps range. You can see it's 5-digit display. So I'm thinking this probably goes down to very low currents. Let's have a look at the specifications. So when I say 5 digits, you probably call this a 4.5, like half a digit. Yeah, fair enough. Update 3 times a second, so that makes me think it might be a bit slow, but I'm not sure if that compares to other multimeters, to be quite honest. Yeah, just 2 at TRMS. Okay, slight spelling mistake there, but okay. This runs on AA batteries, so that's a bit unusual. And a lot of multimeters these days are running on rechargeable LiPo cells. So millivolts range I was just mentioning, resolution 0.001 millivolts. So that is in fact a microvolt. Okay. The same on AC. We can see the current ranges here. Microamp range, so 0.01 microamps. That's like 10 picoamps. Yeah, that might be interesting. There are cases where I need to measure very low currents accurately. And it's also useful, this sort of thing, with the millivolts, microvolts in short finding, in actual fact, okay? I've shown how to do that on my channel a few times. I'll try and put the link in this one. But basically you inject some small amount of current and then measure around to find out where the lowest voltage drop is, yeah? And that is effectively where your short is. Okay, so we have that. Down to 0.01 ohms. Now most multimeters are not very good on low value resistors. We can try. It says down to, well, that's effectively 1 picofarad. Again, I find multimeters are generally not very good with low value capacitors. Frequency range up to 10 megahertz, pretty much. Diode range, continuity, and non-contact voltage. Okay, so that's what we have. Here is our multimeter in a nice holder, carry case. And this is the Zoyi ZT219. So it's a nice, big, chunky multimeter. There's probably a screen protector on here at the moment. Yes, so we can remove that. Okay. We have included, there's a temperature probe. Let's look. This certainly looks like a temperature probe. Okay. And some leads, of course. Let's have a quick look at these. So these are, I think, needle probes. Usually these things clip off. I can see the end of the probe anyway. They're not as sharp as needle probes, but they are quite sharp. Those don't easily want to come off, actually. Okay, so that's the probes we have. Let's have a look first to see how much this costs, and then let's give it a go. Okay, so these were about 30 euros. That's the official store. They have a Black Friday sale coming up. I've noticed that some of these have free shipping. You'll see the same multimeters for about 20 euros, but if you go to these, you have about £10 of shipping. So there really isn't any difference there. So that's the sort of price of this multimeter. So it's not the cheapest, but it's certainly not the most expensive. Let's have a look to see if its performance justifies its price. Well, first thing I noticed, there's actually appears to be no batteries in this one. Let's have a look. This is quite a nice protective type case. battery cover. Okay, so we just need batteries, which are the AA size. It tells us in the little cover which way round they go. So yeah, they actually click into here first, so push that way. Yeah, push that way, fit very tightly, so we can just insert this now. So just bear in mind it doesn't come with batteries. And now it's working, of course. So yeah, we'll do the temperature test first because I'll probably forget otherwise. We can see we have common and we have, yeah, this one shows temperature. Without reading the manual, I'm guessing we hit select to choose the various thing we want. Centigrade. That's my skin temperature. Just get the hot air. Oh yeah, okay. That works just as you would expect. Okay. It's quite nice having that long temperature probe. I'm guessing you could put maybe something like a little bit of heat shrink just over the end so that you're not effectively shorting stuff out when you're touching them. If you want to, you know, do this on a powered up PCB. Yeah. But then the same would apply with a normal thermocouple, yeah? So yeah, quite like that. Now, if you're regular viewers of the channel, will know full well the first thing I'm going to do with this, well, apart from that, is the Mr. Bleep test. Yeah, Mr. Bleep test. So, Mr. Bleep test is the diode and continuity. And what I'm looking for is the multimeter to give a continuous bleep on a short and a single blip on a semiconductor junction. That means when I'm probing around on a board looking for shorts or just generally testing stuff, I don't need to look at the multimeter. I'll show you what I mean first in case you're new here. Here's my very old Fluke and also my ET13S thermal camera multimeter does the same thing. So we go to diode mode. So if we short the leads, continual bleep, okay, and if we go to a diode, one blip, yeah, and it reads the value. So that's the Mr. Bleep test. Let's see if it passes. And most multimeters won't do this. Now, some of you guys I know will say, well, it isn't really important. Bear in mind, my use is repair, and I don't want to be looking at the multimeter when I'm probing the board. I just want to know, yeah? So, at the moment we're in auto, we're now in ohms with a bleeper. That's continuous, but in ohms range, you wouldn't expect it to read the diode, okay? You'd expect it not to do anything. Okay, and then we go to diode mode. So now it doesn't bleep, and I want it to continually bleep now. And now we go to the diode, and we don't get a blip. So no Mr. Bleep on this one. It works the same as a lot of multimeters do. Just a shame it's not implemented the other way. But that's my personal preference. You guys, what do you think down there? Yeah, okay. But it is working and it's quite fast. Yeah, it's responding fast to that, okay. Let's just try a Schottky diode. I think these are Schottky diodes. Let's see. So it should read about 0.15, 0.2, something like that. Yeah, 0.2. So the diode test function works just fine. We just don't have the bleeps and blips. As mentioned, most of my multimeters won't do that either. But Zotek, can we have that please? It's probably just a firmware upgrade. So we'll go to resistance range and we'll also try this on continuity as well. We can manually select the range, Luke. Mega ohms, ohms, kilo ohms. Yeah, that's quite nice. and it's showing us where the decimal point should go. So we'll go first to auto and let's see how it reads this. So this is a low value resistor. It has two 0.22 ohm resistors in series in here. So from the center to either end is 0.22 and right across it is 0.44. Very common values you will find in power amplifiers. So what does it read on auto? Well, it's reading it. Let's go to manual. I want to go to ohms range, see if it does it a little bit better. So 0.5 across the whole thing, 0.4 across there. So this probably isn't zeroed. It's quite close. Okay. I haven't checked in the manual to see if this has a calibration mode. Let's have a look. Yeah, I've had a quick look. I can't see any way to actually calibrate this. I will say it's reading that quite well though. My Fluke, which is a very similar size by the way, on low ohms range, and this does have a calibrate function. Yeah, still doesn't work very well reading these sort of resistors. So this should be 0.44. See, it reads 0.2, 0.1. And this should be 0.2. This actually reads negative. So even when zeroed, and I'll do the calibration again. It doesn't like reading these things. Yeah, you can see that, okay. So it works just as well as that one, to be quite honest. Let's just try a high resistance, then we can have a look at some voltages. But I'm mostly interested in the very low ranges, so microamps and microvolts. This is something I use a lot. Here I have a 10 mega ohm resistor, so I've gone back into mega ohms, okay. What does it tell me? Again, my Fluke doesn't read these very well at this range. That's reading that nicely. Comparison. Actually, yeah, that reads it very well also. So they're working on a par really there. One thing I did notice though, while reading the manual, looking to see if this has a calibration range, is that this has like a 15-minute power down. So if you leave it sitting there after 15 minutes, it switches off. But it says if you hold the select button in while you switch on like that, you get 5 bleeps. You've now disabled the auto power off, which is great if you are sort of working on something all day and you don't want to keep putting this back awake if it falls asleep, but not very good if you forget to switch it off at night. Okay, so we have that. Now then, capacitance. Capacitors on a multimeter usually take a long time to read. The higher the value of the capacitor, the longer they take. So for example, here we have a 100 microfarad capacitor. Let's try it. And it thinks about it and it tells you. So that's very normal. The larger the capacitor, the longer it takes. So we'll try this. This is a 3300 microfarad. Yeah, it takes a little while. It reads okay, of course. Let's have a quick look at voltage. So you can see my bench supply there, set to 12 volts. I'm sure this will measure it just fine. That's a nice clear display, that. This has a light as well, I guess. Yeah, although to be honest, it works very well without the light. I mean, I have a lot of light on my bench. I mean, that is the overhead lighting just there, but it's not very reflective unless I'm shining the overheads directly into it. So yeah, I mean, that works fine as you would expect. Let's have a look at the microamp and the microvolt range. Let's see how good they are. So probably the most common reason I want to look at microamps is to measure the current draw on a CMOS battery, because this gives me some good indication of what's happening with the chipset. So microamps, milliamps are on this one. So milliamps range, this probably won't read much. So this effectively is a microamp. So we might see 1 or 2 there. Let's have a look. So red on the battery and push back with the black. So that's not drawing enough current to register there. Can you see that? Okay. Let's go into the microamp range. Range. Yeah, we can move the decimal point. So that's the most sensitive. So this is down to 100. It's 0.1 microamps. That's about 10 picoamps. So on the lithium cell, push it back. Yeah, and look, you can see it clearly. 1.96 microamps. So this works absolutely fine for measuring something like that, and that's the sort of value you'd expect as well. Okay. So with microvolts, I normally use this when I'm short circuit finding, if I want to inject some current but not enough to get something hot, or if like the short is an absolute short somewhere and it won't get hot anyway because there's no resistance in the short, so it can't dissipate any wattage. Yeah. So the way this technique works, we'll just turn the current quite low on the power supply. You can see it there. Short the supply. So I'm going to set a fairly low current of about half of an amp. Okay. This means you're not likely to damage anything on the circuit board or any tracks on the PCB. Okay. And I've now applied that. We can see that the power supply has gone down to 0.01 volts. So if I now go on to millivolts on my meter, and again we'll find the most sensitive range. So this is millivolts with 3 decimal places. So if I now measure, we know the short is there, but I'm going to measure here across the wires, and let's see what we have. And it's actually above what I can read. Okay, it's above the maximum on this range. We can just go up a range. Okay, so I'm up to 19 millivolts. I'm about 127. Okay, now the closer I get to the short, the less that will become. Look, 73. Okay, 7. And on the short itself, 0.08. Okay, you can see that. So just effectively, if I slide this up and down here, you'll see the voltage increase, and you'll see it decrease. Okay, so that's why I use that range, and this is very sensitive. I mean, this is the most sensitive range. Yeah, 0.8, it's 883 microvolts. So yeah, that works great for that use, and that's a common use I have. We also have NCV, or non-contact voltage. So this is where you just put the probe near to something like a mains lead. Yeah. Yep, working fine. All in all then, I would say for the price, this is quite a competent meter. It has a stand as well. I mean, that's clear for me to look at, obviously better like that for you guys. Nice clear display. What do I consider to be the best features? Well, 20 amps. This is the only meter I have which has 20 amps. That's great. The microamps worked really well, you saw that. And also the microvolts is extremely sensitive. Those are features I use, maybe you don't, but I do, so that worked fine. The temperature probe, well, it was included, you know, and I mean, this was like sort of best part of €30, something like that. So I'd say it's a price for what it is. It's big and chunky. Yeah, solid. If those are features you want, nice big display, high currents, accurate on the microamps, millivolts, I'm fine. And I'll use this. This will get used. I'm often working with more than one multimeter. I mean, so far I do not have a single multimeter that does everything I want. So the Fluke is great with that Mr. Bleep shortened diode finding, but it's rubbish with low value resistors, and it's not sensitive enough to do what I was just doing with this, to find a short. Okay, so I often use my little Aneng meter for those features: low current, microvolts, and low resistances. But then the Aneng doesn't have a particularly good display. You can see that. I mean, mine is a bit worn, I'll be honest with you, but it isn't particularly good. Even with the light on. Yeah, so it's fine for use, but for making videos this is far better, far clearer. You can see that. Admittedly, this is a much smaller multimeter. The Aneng 8008 also does not pass that Mr. Bleep test. The only other one I have that does is the ET13S, which has the built-in thermal camera, but that's not so good as this with the low microamps, you know. So it's kind of horses and courses, really. Guys, consider what your main use is. Yeah, consider which features you want the most, and then make a decision. And no matter what you decide, you'll probably end up with more than one multimeter anyway. I mean, let's face it, you can never have enough multimeters, yeah? Hope you enjoyed that, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.